Hey, my name is Connor Loffenberger, and today I will be walking you through how to solve question 3 on the FRQ portion of the 2004 AP Calculus BC exam. Now remember that because this is an older FRQ, the first 3 questions are calculator instead of the first 2 questions which are calculator now. Therefore, this is a calculator allowed question. Let's start off by reading the setup. It says an object moving along a curve in the xy plane has position x of t, comma y of t at time t is greater than 0, greater than or equal to at 0, with dx over dt equaling 3 plus cosine t squared. The derivative dy over dt is not explicitly given. At time t equals 2, the object is at position 1, 8. Now, part A asks you to find the x-coordinate of the position of the object at time t equals 4. So the question asks for the x-coordinate, however, we do not have the position function. We do, however, have the rate of change of x, as well as the position of x at x equals 2. At t equals 2, I'm sorry. So, since we're solving for x at time t equals 4, we can take our x of 2 and add it to the integral from 2 to 4 of our dx over dt. And in the setup, we learned that at time t equals 2, the x is 1, and then we can add this to our integral, which is 3 plus cosine t squared dt. Now this is where the calculator comes into part. So we can add 1 to our integral from 2 to 4 of our dx over dt plus cosine squared. I'm replacing the t with x's, by the way. Doesn't change anything. And this is our integral, and it should get us an answer of 7.132. Part B this time asks for the tangent line at x of 2, y of 2. By looking at our setup, we know that x of 2, y of 2 is equal to the point 1, 8. In order to find the tangent of a line, we have to find the slope at that point. The slope is equal to dy over dx, but in terms of our problem, it is best represented as dy over dt over dx over dt. This problem gives us an equation for dx over dt, and it also gives us our value of dy over dt at t equals 2. Given this information, we can determine that dx over dt, or dy over dt, dy over dx, I'm sorry, equals dy over dt over dx over dt, which is the same as negative 7 over 3 plus cosine of 2 squared, which is 4. Therefore, we can find our slope of negative 2.983. Since we have the slope and the point of the tangent line, point slope form would probably be the easiest to use. Finally, we get the equation of our tangent line to be y minus 8 equals negative 2.983 x minus 1. Sorry about the lighting, it just got super bright really quick. Part C asks you to find the speed of the object at time t equals 2. This problem is fairly straightforward depending on your knowledge of the speed equation, which is the absolute value of the velocity. Therefore, our speed equation, or all speed equations, are represented as the square root of x prime of t squared plus y prime of t squared. Now since we're solving at time t equals 2, we're solving for x prime of 2 and y prime of 2, which happen to be the same values we used to find the slope in the previous problem. So we're squaring 3 plus cosine 4, and we are adding it to -7 squared, which is 49. Now to make this easier, we're just going to plug these values into a calculator. So we're going to root it. 3 plus cosine 4, square that, plus 49. Should give us our answer of 7.383. So part D asks you to find the acceleration vector at time t equals 4. It also says for time t is greater than or equal to 3, the tangent line to the curve x of t, y of t has a slope of 2t plus 1. The x value of the acceleration vector is fairly easy to find. We already have our x prime of t value, so all we have to do to find the acceleration of that is to find the derivative of our x prime of t. So dy over dx at, where it asks for at time t equals 4, of 3 plus cosine t squared. So this is our x for the acceleration. We can use our calculators. Go down to our derivative. Derivative of 3 plus cosine x squared at x equals 4. So this will give us our value for the x of the acceleration function. So the only number we can get, x double prime of 4 equals 2.303. There is no rounding. Any rounding would be incorrect. You won't get any credit for it. Alright, now we're on to y double prime. Finding y double prime of 4 is a bit trickier than it is finding x double prime of 4. We know that y prime of t is equal to dy over dt. Therefore, it also makes sense for dy over dt equaling dy over dx. dy over dx times dx over dt. Because in all these two cancel. So then using the reason we use this switch, we switch the form, is because we are given the slope 2t plus 1 for time is greater than or equal to 3. So by just adding our known variables, we can determine y prime of t equals 2t plus 1. And then we plug in our dx over dt, which is 3 plus cosine t squared. Now we can solve for y double prime of 4 the exact same way we did for x double prime of 4. So again, we choose the derivative of 2x plus 1 and multiply it by dx over dt, which is again 3 plus cosine of x squared at x equals 4. Where's 4? Now this gives us a value of value of 24.813, 2.303, and then either one of these values, I'm just going to choose one. This would be a correct option, or you could do 24.814. So that is how you solve all 4 parts of question 3 on the 2004 AP Calculus BC exam.